This is lesson 3.4 on slopes, parallel lines, and perpendicular lines. A slope is generally defined as the rise over the run. The rise being the difference in your y-coordinates and the run being the difference in your x-coordinates. Let's find the slope for line A. The blue line right here is line A. Note that they give us 2 points of the line, the point 64 and the point 82. We're going to use this formula right here to find the slope of the line. The y-coordinate for the second point being 4 minus the y-coordinate for the first point, which is 2, gives us a difference of 2. Let's take a look at the denominator. X of 2, being the x-coordinate of the second point, is 6, minus x of 1, which is the x-coordinate of the first point, 8. 6 minus 8 is negative 2. So dividing 2 by negative 2, we get a slope of negative 1 for line A. Notice that the slope for line D, the red line, is y of 2 y of 2 minus y of 1 divided by x of 2 minus x of 1. Note that when you find the difference in the denominator, you get a difference of 0, which is undefined. Therefore, we say that the slope for line D, which is a vertical line, is undefined. Now it's your turn to practice. You're going to find the slopes for lines B and C and include them in your notebook with your notes on the previous lesson. Now let's talk about parallel lines. Parallel lines have equal slopes. Let's take a look at this problem here. We have 3 lines and we want to find out which lines are parallel. In order to do that, we need to find the slope for all 3 lines and then see which ones are equal. Let's begin with the blue line, K1, and find the slope for that line. Y of 2, y of 2 minus y of 1 is negative 4. Now let's do the difference in the x-coordinates. Negative 3 minus negative 2 is negative 1. So the slope for line K1 is 4. Next, let's find the slope for line K2, or the red line. And again, we're using the same formula that we used before, which is y of 2 minus y of 1 divided by x of 2 minus x of 1. So y of 2 minus y of 1 is negative 4. Now for the difference in our x-coordinates, 3 minus 4 is negative 1, and negative 4 divided by negative 1 gives us a slope of 4 for line K2. We can see that these two lines are parallel because their slopes are equal. We still have to find the slope for the green line, or line K3. To find the slope for line K3, we again subtract the y-coordinates. Negative 2 minus 3 is negative 5. Now for the x-coordinates, 5 minus 6 is negative 1 for a slope of 5. Because K1 and K2 have the same slope, they are parallel. However, the slope for line K3 is different. Therefore, K3 is not parallel to either one of the other two lines. Now it's your turn to practice. Answer the following question. If line M passes through negative 1, 3 and the point 4, 1, line T passes through negative 2, negative 1 and the point 3, negative 3, are the two lines parallel? Explain how you know this. This problem should be included in your notes. It will be graded. Let's talk about perpendicular lines. Remember that perpendicular lines are lines that meet to form right angles. These lines have slopes that are negative reciprocals of each other. Therefore, m sub 1 times m sub 2 is equal to negative 1. Let's try an example. Suppose that line H passes through the points 3, 0 and 7, 6. Here's line H, the blue line. And we want to graph the line perpendicular to the blue line so that it passes through the point 2, 5. The first thing we want to do is find the slope for the blue line. So we have 6 minus 0 equal to 6 for the difference in the y-coordinates, and 7 minus 3, which equals 4, that's our denominator for the difference of the x-coordinates. Reducing this fraction, we get a slope of 3/2 for line H, or the blue line. Since the perpendicular to the blue line will have a slope which is a negative reciprocal of 3/2, we can use the formula m sub 1 times m sub 2 equals negative 1 to find the missing slope. The slope for the blue line, or m sub 1, is the one that we just found to be 3/2. The slope for the desired line, which will be perpendicular to the blue line, is our m sub 2 here in this formula. And we set the product of those two equal to negative 1. So now we're going to solve for m sub 2 by multiplying each side of the equation by 2/3. So we get the slope for the second line, or the red line, should be negative 2/3. So now that we know the slope and we know one of the points of the line, we start at that point, which is the point 25, and we're going to go down 2 units and over to the right 3 units to find the point where it intersects the blue line. Note that we use the slope to find a second point on the desired line, which is the red line in this case. Here's a practice problem for you, and don't forget to include this practice problem in your notes. It will be checked.